Hello, everybody, and thank you for coming to this session, and hope you are enjoying Devoxx. Today is the first day of Devoxx, and in this talk, I'm going to talk about secret management in your applications, and I said applications, but also applies to microservices applications or architecture as well. So my name is Alex Soto. I'm a software engineer at CloudBees. But also you can follow me in other team members like the Killian community, Tommy Thrive, ASCII Doctor, NoSQL, and also I'm a member of the GSR 374 expert group, which is the JSON processing API. Also, I'm the co-writer of the Apache Tomcat JSON ref card, and I'm co-writing a book, or Killian in Action, with my friend Jason. So first of all, let me ask you, how many of you are encrypting the passwords that you set on your resources files? Like, for example, database password, GMS password, and so on. Yeah, quite a few. I think that this is something important that you need to encrypt these passwords as well, because if you lose this file, anyone can access to your system, to your database or your GMS key or whatever. So it's important to encrypt it. Let me show you an example of this is Apache Tommy example, which is a resource when you set the URL, the username, and the password. In this case, the password is in plain text. So if you lose this file, everyone can get the password and access to the database. The good news is that Apache Tommy provides out of the box something that it's zippering the password. So for example, in this case, I'm putting here the driver and the URL, the username, and the password is a chunk of bytes, which are encrypted. And then you can set here which zipper you want to use. In this case, AAS. Okay. And of course, if you are not going to use a database, but you want to use some other kind of resources, you can do zipper : the algorithm and the chunk, and then when Tommy boots up, it simply takes this chunk, takes the algorithm, decrypt, and gets the plain text to your application. So probably your code will be something like this, which is I read the key, and it seems that it has sense that you have a symmetric key. So you read the key, you create the secret key spec, and then you have a decrypt method, which you get the algorithm, you put the secret key, you want to do a decrypt mode, you get all the things from the chunk, and you return the clear text. It seems pretty simple, and you said, okay, now I'm encrypting my resource file, so I'm done, I'm secure. But you're ending in a chicken egg problem. Why? Well, because, as I said, you are reading from disk your symmetric key. And if someone takes the symmetric key, can decrypt the password and get the password and the login of your database, for example. So you can think, OK, I'm going to encrypt the key. But again, you need to provide a key. And this is the chicken egg problem. And it seems that there is no solution for this. Well, yeah, it seems that there is no solution. And let me now show you in case of monolith applications or architecture. Something that worked for me in the past was this approach. Something like, OK, we know that we are facing a chicken egg problem. So what we are going to do is encrypt the password. It's one part. And the other part is creating a file with the key inside. So basically, you take this key with the file, you put it on your application server in a special directory, and when the application server boots up, it goes to that place, it takes the key, it decrypts everything that it has configured, and then delete the file. Well, it can work because if you have an attacker that have access to the disk, they will not read the key, so it won't be able to decrypt the password. It works, but it has some problems, is that how you manage the access of this file. This file is in a USB drive. There is an operator that have to go there and copy that file. Yeah, it has some drawbacks, but it works. The problem is what's happened with a microservices architecture, where you have a lot of services. In these cases, of course, you can go to all of the services and install that magic file. But yeah, you are spreading the problem across all the infrastructure. So if one service has a bug and someone can access to this file, all your infrastructure is compromised. So in case of microservices, this approach is not the best one. But also, you can have other problems. For example, if you're using a cluster manager, which boots automatically your services, and if, for example, one service is down, then it restores again, automatically, or is a system that you can dynamically scale your solution from having one instance of one service to 3 instances of that service. It's quite impossible that you need a manual step that implies copying something inside a specific directory. So it seems that this solution, it may work for monolith architectures, but not for microservices. But the good news is that there is one project called Bolt. Bolt is a project from HashiCorp. HashiCorp is the company that created, for example, Vagrant. And Bolt is a tool for securely accessing secrets. And yeah, and a secret is anything that contains a sensitive information, a password, a key, whatever you need for your application that if someone stole, then you appear on the news. No, this is a secret. And you can think about Bolt as a secret management as a service, because at the end, it's a service that you connect from your application, you basically put things and you get things from there. So it works pretty well in a microservices architecture. So what are the Bolt features? The first one is that it's a secure secret storage. And you can think this as I explained now, something that you put a value there in plain text. Bolt encrypts it and stores in memory or in disk or in etcd or in console or in a database. You can define where you want to store the secret. And when you get the secret from the Bolt, it takes the secret, it decrypts, and it sends you to your service or the caller. Okay. So in this case, it offers a secret way to storage things. Also, it has something that is called dynamic secrets, which basically it's a way to generate secrets on demand. Probably in your application, if you have a database, you are setting a user and password, for example. And what's happened if you didn't, or you wouldn't have to set a login and password? Then you wouldn't have that problem of having to encrypt everything. And this is what dynamic secrets do. Basically, you, from your application, talks with Bolt, saying, I need a login and password for accessing to the database. And then Bolt says, OK, I'm going to talk with the database you've configured. I'm going to create a user and a password on demand, dynamically, and I will return to you this user and password. So from the point of view of your application, you don't need to store login and password in any place, because it's generated dynamically. Also can be used as a data encryption, which can be thought in some way as encryption as a service, which means that you send something in plain text to Bolt, Bolt encrypts and returns the value, but this value now it's not stored anywhere. So you don't need to, take care of where this thing is stored. And for decrypt, it's exactly the same process. you take the chunk, you send it to Bolt, Bolt decrypts, and sends you in plain text. And this is pretty interesting because now all your services can use the same code for encrypting and decrypting things. Everything in Bolt has some time to live. It means that after this time, it's deleted from Bolt, the secret. But of course, you can renew the secret, and it also have a system of revocation, which means that in case you detect that someone has entered to your system, you can revoke everything, and no one has access to your application from that point. It has a system for auditing, so you can see what's happening, who is asking for what. It has a rich ACL system for applying roles to who can see what. And one important thing is that you can access Bolt as a standard user, but you need to use some of his authentication methods. And it's pretty interesting. We are going to go deep in a bit, but Bolt has different mechanisms, some user-oriented mechanism, like, for example, username and password, or token. But there is also other methods which is machine-oriented, like, for example, a PPID or TLS, or something that is more focused on machines. And as a server and as a as a new product, it works with REST. As you can see, Bolt does a lot of things, but in this presentation, we're going to be focused on secure secret storage, which means that we are only going to put things inside and get things from the application. Let me show you in action. OK, I've got Bolt running. The first thing I need to do is initialize. And this is Bolt init. And one important thing, and I'm going to explain you now what I'm doing. Now, what I need to do is create a key for encrypting everything of Bolt. So when I do an init, I create a key. But by default, Bolt is sealed when you init. So you need to unseal Bolt. And how you do this? OK, you could use some username or password, but instead of this, it's going to take the key that is going to be used to encrypt and split it in several chunks. OK, and then you need to define how many chunks you need to provide to unseal the Bolt. This is a Shamir algorithm. I mean that it's nothing that has been done by Bolt. And in this case, I'm saying that I'm going to init Bolt, and I want you that you share the key in two chunks. And when I unseal the Bolt, I want that you provide both tokens. Bolt init, sure, yeah. Shares. Now, as you can read here, it says that Bolt is initialized with 2 keys and a key threshold of 2. Please securely distribute these keys and so on, and you must provide at least 2 of these keys. So to do this, then we want to call Bolt unseal, and we're going to get the first key. And it says, OK, it's still sealed. You have provided 1, and you need to provide another 1. So we're going to take the second key. And that's all. Now, Bolt is unsealed, and everything is OK. Now, what we need to do is authenticate against Bolt. And to do this, I'm going to access as a root. And notice here that Bolt said, this is the root token. So if you distribute this token to anyone that don't need to be able to have root access, then yeah, they have root access. It's like if you share the user and password to the wrong user. So I'm going to do Bolt auth. And wait. No. Let's try again. OK, now I'm authenticated. And now we are going to store something there. The first thing that you need to provide is when you want to use the secret secure storage, you need to start with a secret. This is like the mount system, like in Linux. And then you put here whatever you need for your business. And now you can set some properties, for example, user, foo, password, bar. And it says, OK, you have written this and secret / hello. And then this is encrypted now. So nobody, if you access to the disk, you will get a chunk of bytes encrypted. And to get it, you called bolt read secret hello. And you get the key, least duration, because as we said, there are some time to live in all the things that you store in Bolt, and then all the properties, the password and the user and the password. This is how you can store and get things securely from Bolt. But, yeah, we have talked that we want to do something to manage securely the secrets in a microservices architecture. But now, as you have seen, I've used the root token. So with the root token, you can create new tokens more restrictive than the root. But at the end, you still have a chunk that you need to distribute everywhere. So if you lose this chunk, someone can enter to Bolt and get your symmetric key, and with the symmetric key can decrypt the database password. So we are still in the same problem, but yeah, it's more difficult. But this is what Bolt tries to fix. And tries to fix with one authentication method, which is called a PPID. Basically, a PPID is a method that is machine-oriented method. So don't try to, do it by your own manually, because you're going to spend a lot of time. And basically, it's based on providing two elements to access or to authenticate. So your services need to provide two things. The first thing is an PPID. An PPID is a random unique chunk of bytes. You can generate it with a random or a UUID or whatever you want. It's unique for the application. I mean that each of your service or microservices will have one IPPID. It's generated by an operator. Someone decides that I'm going to run this code, and then you will get a chunk of bytes, and the service one going to have this chunk of bytes. In our case, we use Jenkins to generate this. And this chunk is stored on your configuration management system. And this depends on what you use, if you use console or wherever you use. This is one of the things that your service will need to provide, this APPID. And the other thing is the user ID. And the user ID is an intrinsic property. An intrinsic property, I mean the IP, the MAC address, maybe the hash of both, the host name, whatever that is intrinsic to that machine. And it's unique for each instance. So for example, if you have one service and that has two instances on your infrastructure, you will have one IPPID and two user IDs. It's generated by Cloud Init script. Well, this is If you're using Docker, you're going to use in one way. If you're using Mesos, you're going to do in another way. This depends on your system. And it's, as I said, it's like this. You have service 1, to service 1 deployed in 2 different machines, and to service 2 deployed in 2 different machines. And you have 1 application ID for service 1, 2 user ID for the service 1, 1 application ID for the service 2, and 2 applications ID for the service 2. Of course, if you had 3 instances of service 3, you will have 3 user IDs. So each service, when it wants to authenticate against both, to gain access to get secrets from there, it needs to provide the tuple of PPID and user ID. If they provide both and are valid, then we'll get access and you will be able to get your symmetric key from both, or your password, or whatever you stored. And if not, it will fail. Let me show you an example. Wait. Yep. Well, in this case, it's Java code. I created, a Java interface between, Java program and Bolt using Feign. Well, this is. Then what I'm doing here. Well, let me first of all restart Bolt because it's already initialized. So what I'm doing here is, first of all, I init Bolt with only 1 key, and you need only 1 key to enter to Bolt. Now here there is the search things. Then what I'm doing is unseal Bolt, which basically provide the key that has been returned by init method. The next thing is I enable the backend PPID. Remember that in our example we use secure storage, which is mount by default in the secret / blah blah blah. This means that it's Bolt. But in this case, by default, PPID mount system is not built. So you need to mount it manually. So in this case, I'm enable auth backend, mounting it. Then, well, it's OK. Then I generate an PPID using a random PPID. Then I send this PPID to Bolt to say, hey, keep in mind that there will be one service that will send you an PPID. You save this. Finally, I'm setting here that I need a user ID. And basically what I'm doing here is getting the host address. I do the SHA-1, and I send it to Bolt. And in this way, I will say to Bolt, remember that I send you an PPID. Notice that here I'm setting the PPID, so I'm saying, and now you're going to receive a user ID, which is related to this PPID, and if you receive both of them, you can get access. And this is, you can get access is this login here. So if now I run this, there's a script, yeah, it's obviously it's green. And you can see here that when you log in, I receive a token, because in Bolt, everything is a token. So now, in all the other operations that I will do from Java, I will need to provide this token. So when I want to get something from there, I will call get method passing this token. And I will get access to the information. And that's all. It's really pretty simple. But as you can see, now I've explained it in a Java code, everything, but you are wondering, OK, but I run in production. I'm not running in this way. And since maybe you are using Mesos, maybe OpenShift, maybe Docker Swarm, I'm going to show you an example with Docker that we use in my company, OK? Or in my previous company, just in this case. And it's this. We had a Jenkins. And the first thing that we did is, I'm going to create a new service. So the first thing that I do is I have a job in Jenkins and say, give me the name of your service and generate me an PPID. It's a random, it generates a PPID. And then we had a base Docker image. Then it takes this base Docker image, and it adds in a Docker file based on this base image, this PPID with the name of the service. So all the services that are of type A are going to have this Docker file. If I need to create another service, service B, I need to do exactly the same process. Then we have the PPID, which is one from service. Well, this is that when we finish everything, we connect to Bolt and we register this PPID. This is one part that is done one for each service. So it was, when we start the development of that service, we did this. But then there is all this hard thing, that is how we deal with the user IDD. And basically, we do the next thing. First of all, we use a sidekick Docker image. So when we started our service, we started another container in the same host address, and basically, it takes the host name and IP, it makes the SHA, and it connects using mutual TLS or cubehole approaches. It authenticates to Bolt and sends the user ID. Obviously, if we start a new instance of the service A, the host name and the IP will be different, so it's perfectly valid. Then, since the Docker image we use was based on this Docker image we use, we inject the PPID to Apache Tommy in this case. So now the Apache Tommy has the PPID. Then, since Apache Tommy is running in the same host address of the sidekick Docker image or instance, the hostname and IP was exactly the same. So we authenticate, so we create the SHA of the hostname and IP, and we authenticate, this is the code that we have seen, sending the, the PPID and the user ID to Bolt. Now, after that, since we were providing an PPID which is valid because it comes from here, and we provided an user ID which is valid because it's the hostname and IP of this instance, that at the same time is the same instance of this one, we would be able to read data from token. We get it, in this case, the private key. And finally, we remove the token of the user ID from the private key from user ID. So if someone in the middle, gain access to Bolt, then can get this key. Well, we are finishing, but let me tell you that, first of all, Bolt is a service, and as a service, it needs to be deployed in your infrastructure. So if you're using Docker, put Bolt in Docker. If you are using Mesos, use Mesos with Bolt. It needs to be configured with high availability. So, I mean that if Bolt is down, yeah, you will lose all the access to your secret, so you need to replicate it, monitor it, and think that it can be used for monolith applications as well. And also, as a final note, is that there is no silver bullet in security. You can only put fences and fences and fences, and if someone breaks one fence, you will have another, if not, you have another. And this is what Bolt does. It's adding fences as a defense for your application. And we have 1 minute for questions. Great. Here is the slides. If you want to review it or something, you can take it. And if you want to send me an email asking any question, don't hesitate to do it. Thank you.